Hey, this is a quick test to show how Cognex Designer can scan in a 3D image and look at information about that 3D image. So what we're looking at right now is a chicken breast, and we've got several different 3D scans of that chicken breast. I'm just going to run through a few different ones and talk about the differences in the images that we're looking at here. So as you can see, I'm running through different randomly placed breasts, top side up, bottom side up as well, and I'm just manually clicking through a database of 3D images. Just to show you a 3D image, that's the raw 3D image of a chicken breast, and so you can see it from all different angles. And as we run through this, we can see all the others at different angles as well. Now they're on a conveyor belt, and on that conveyor belt works well for us because it becomes our base plane for doing height and volume measurements. But you can see them all scanned in one at a time. We can also extrapolate from this 3D image. We don't really analyze this. What we do analyze is a 16-bit 2D image where we've got width, we also have height, and then we also have, width, length, and height data all wrapped up in this one 16-bit image. This has been colorized. I can easily color map this to be any variation of color I want it to see. You could go with a thermal color palette. I prefer to just go with height. I think it looks nice. But this is just for human consumption at the HMI. This is a height graph, so I'm just graphing height from top to bottom. Haven't fixtured it to any particular part of the breast, but just mostly right across the thickest part, so that as we run through images, we can look at this graph up here and we get a quick, easy representation of the highest point on the breast, and the height data from here is also the same data that's being displayed down here. Now we also have a volume tool that is measuring the volume from this base plane of the conveyor belt and measuring the volume of anything above that plane, which would be the full breast. And over here I just have it in cubic millimeters, and of course we could convert that to any other unit of measurement that you want. But it's a quick, easy run through of individual breasts for height and volume. I didn't go into measuring widths, but just as you can see, however you want to define a width, but you could define the widest point at the maximum, the longest end to end. If you wanted to know something about the shape, meaning typical angles for types of breasts and typical parts of a chicken breast, they could all be identified as well. Just depends on what we want to do with the data once it's extracted. Anyway, that's all we have here.